Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we'll work through a complete F-test example using the sum of squares formula. So we'll go step by step to identify the hypothesis, compute the F statistic, and then make a decision by comparing that to a particular F critical. In a general case scenario, where let's say that you have a regression with K regressors, the F-test is going to ask you, do these regressors jointly explain variation in Y? And formally, you would write the null hypothesis as beta null equal, beta 1, starting because beta null is just a constant, beta 1 equal to 0, and beta 2 equals to 0, and so on until we get to beta k equals to 0, with the alternative hypothesis being otherwise, meaning at least one of these betas, one of these slope coefficients, is non-zero. But what does that look like in an actual example? So let's assume that we have the following scenario. And in here, you'll see this is a skeleton of what a data output would look like. I have erased all of the other information, but I've left the minimum information that we will need in order for us to conduct the F-test. Normally, these numbers would have been given to you, so you wouldn't have a need to make these computations, but I'm just going to show you where all of the numbers come from so that you get also a better sense all the time what this data output is giving to you. So you have been given here the explained sum of squares, so the model SS 240, the residual sum of squares at 360. We've got the number of regressors, 3, which is given to you by these degrees of freedom of the model 3. So keep in mind, these 3, it's literally telling you you have k equal to 3. So if you had to fill in yourself the regression line in here, the command would have been regress y on x1, x2, x3. And what you would have seen in the lower part of the table in here would have been y in here and x1, x2, x3, the constant being always there for any regression that you run unless you have said that you don't want a constant in it. But for that, you'd have to give a command. So degrees of freedom 3, and we have the total 100. Keep in mind, this total of 100, it's literally your sample size. Okay, so if you have to fill in number of observations in here, the 100 would show in there as well. What does that mean for the degrees of freedom of the residual? Well, keep in mind the degrees of freedom for the residual was n minus k minus 1. So we can actually fill that number by ourselves because it's just going to be 96 in this case. Can we fill up any other numbers based on what we have? And the answer is yes, because we already have everything we need in this table. So let me start, before we compute anything, let me start by reminding you that the sum of squares formula for the F-test is going to be the explained sum of squares divided by k over the RSS residual sum of squares over n minus k minus 1. So far, it seems that we've got the k, n minus k minus 1, ESS, and RSS. So technically, we have all the elements that we need to compute that F-test. And again, these compares explained variation per regressor, which is this part right here, per regressor, because it's being divided by k, to unexplained, the residual, variation per degree of freedom, which is n minus k minus 1. There's two ways to go about it. You can very easily input all of the numbers in here and compute it, or you can do it step by step by first computing the mean squares. Why the mean squares? If you remember from the previous video, in this first block on the left-hand side in here, the mean squares was in this particular column right here. But there was a way to compute that information directly from the other information in this part of the table, in this block. So when I'm actually saying, let's compute the mean squares, I'm technically telling you, let's compute the numerator and the denominator separately and then put that together to get the final number. Because this first one is the mean square of the model, while the second bit in here, it's just the ms of the residual. Now, if you remember from the previous video, if we divide the sum of squares of the model by the degrees of freedom, then we're going to get the mean square of the model, which in this case, 240 divided by 3, it's simply 80. For the residual, exactly the same, 360 divided by 96, which should give you 3.75. Okay? Now, we have the mean squares, which means now we have the values for both the numerator and the denominator of the f-test. So it's 80 divided by 3.75, which should give you approximately 21.333. This is your F statistic. Okay, so if you were to actually input this number into the table, it would have shown right here. And we can fill it up because now we know that the 2 degrees of freedom that I'm looking at is the degrees of freedom of the model and the degrees of freedom of the residual. So 396. And I just computed the value for it, which is the 21.3. Okay. Now it's time to compare the F statistic to a critical value or compute a p-value. Normally, the p-value would have been given to you right here, and you could have just compared that to your significance level 1, 5, 10%. Since we don't have that information and we're just learning the most basic by using the F statistic value, let's do that. The fact that you have a number which is so big, like 21.3, should already be, in a sense, your indication that very likely you're going to reject the null hypothesis. And keep in mind, the null hypothesis in here is, again, that beta 1 equals to beta 2 equals to beta 3 equals to 0. So all of them should be 0. Most likely, and the best way to write it is actually beta 1 and beta 2 and beta 3 equals to 0. Okay? Alternative, otherwise. So at least 1, 0. So let's look into the actual table, F table, to convince ourselves that, yeah, this big number is going to make us reject the null hypothesis in here. Under all the assumptions being fulfilled, so this F star that we just calculated should be distributed under a F distribution with degrees of freedom 396. Now, if you are worried that you are not going to find a 96 in the table that you're looking at, don't worry, just take the closest number to it, which is very likely the 100. So, for instance, here I've just taken critical values, just like the bottom and top part of an F table, because obviously it was very long and we didn't need all of those values. But I took that for 5% significance level. We know that we're looking for a critical value for F with degrees of freedom 3 and 96. So the closest we're going to find, 3 being the column anywhere in this column right here. And as I said, 96, even if we're not able to find the exact number, the closest to it is the 100 in here. So the way where these two intersect is 2.696. Going back, so we have a F critical 5%, 3, 100 in here is going to be, sorry, I forgot, 2.696. Which very clearly is smaller than the F star that we just computed, which means that we actually reject the null hypothesis. If I had to draw a graph here, the same way that we always did for the t-test, keep in mind with the f-test, I'm going to start from 0 here, and I need to have a right tail distribution. What I can do is my F critical that says here, the 2.696, anything to the right of this is where I reject my null hypothesis, and very clearly the 21 would have been to the in this right tail somewhere like very far out here, which means, yeah, we have evidence to reject the null hypothesis. Now, keep in mind that if you reject the null hypothesis, in this case, does not mean, so it's not equal to saying that all coefficients are significant. Okay? And it's also not equivalent to saying that the model is causal. It just means that taken together, the regressors improve the model relative to using the mean of your y variable by itself. Okay? So the SS-based F-test is computed directly from the numbers that you get from your regression output, and then by comparing model and residual mean squares. In the next video, we'll do the same test, but using the R-squared base formula. So stay tuned, and I will see you in the next video.